In today's class, we are going to see the next one. That is what Newton's second law of motion. So that is what it is a common concept for a NEET and as well as board exam and as well as IIT JEE also. So all of you, let us discuss. So this is not a new at all. What we studied in lower classes only. So laws of motion, Newton's second law. Newton's second law of motion. Okay. So let us discuss now what it is and how it is, everything. So observe very carefully. We all knows that Newton's first law. So what is Newton's first law? The net force is equals to how much? Net force is
Zero.
equals to zero. So this is what we used to call as Newton's first law of motion. Now coming to the Newton's second law, so which is very popular in whole mind, and even every one of you people knows. So Newton's second law of motion. So anybody can tell me what is Newton's second law of motion? F is equals to force is equals to mass into acceleration. Yes or no? So this is very popular in whole over the ninth class we studied. Am I right?
Yes, sir.
So if you observe very carefully here, we will use the second equation in many cases in our daily life. So this is what we studied in our whole ninth, F equals to ma. Even second, force and laws of motion, second chapter, force and laws of motion, Newton's laws of motion, first law, Newton's second law, only this one. So even you might be remember ninth class, those who studied it. So F is equals to ma, rate of change of momentum, we used to call it as force. Am I right, everybody? Rate of change of momentum is only we used to called as F equals to ma formula. Yes or no? So momentum formula. What do you mean by momentum, brothers? Momentum is equals to mass into velocity. So that is what rate of change of velocity. So rate of change of momentum only. Momentum symbol is P. Is only we used to called as Newton's second law. So this Newton's second law, we're having many applications like in pulleys cases. Okay, so when we are lifting the weights with the help of a pulleys or in inclined surfaces with the help of a pulley, if you are lifting the loads and all. So this all the cases we will use this Newton's second law. So that is what we are going to study in our today's class. So if you observe very carefully, so the rate of change of momentum is only we used to called as what actually force. That is what the force applied. So that is only we studied in class 9th. So change in rate of change in momentum, which is equals to force applied. So if you all observe very carefully, rate of change in momentum means what is the change in momentum, everybody? So delta, everything change in momentum, change in velocity, everything we represent with a delta only. Am I right or wrong, everyone? So that is what
Yes, sir.
change in momentum divided by change in time. That is what we used to call as force. So this is what we used to call as Newton's second law. Of course, we will study many things. So but standard equation of Newton's second law, which we all knows, what is that? F is equals to everybody. F is equals to m into respond.
Yeah.
Okay, so now as we all knows that momentum, what is the formula? Momentum P is equals to all of you. So momentum P is equals to mass into what? Mass into velocity. Okay, so let me take now, for example, if I consider object having a mass m and whose initial velocity u and somebody is applying the force F. So within a time period t, the body attains a velocity of v. Velocity of what, everybody? Please respond. Velocity is what? V. Clear, everyone? So as we all knows that force, applied force is increases. Velocity increases or decreases? Force increases. See here, if the force is increasing, then velocity of the body increases or decreases? All of you. Velocity also? Yes, please. Increases. So first initial case, what is the momentum? Can anybody tell me? Initial case, let me take the initial momentum Pi is equals to Mass into velocity. Velocity is what? U. Same way, what is the final momentum? Anybody? PF, final momentum is equals to, respond fastly, mass into velocity V. Is it okay, Ra? Pradosh? That is one. Now, so we all know that F is equals to what? Change in momentum divided by change in time period, which is equals to, so change in momentum means what will come? Final momentum minus initial momentum divided by time. So that is what, if you substitute the formula, again 9th class, same thing we are solving, nothing we are doing new. So final momentum is mass into final velocity minus initial momentum means mass into initial velocity divided by time period. So m is common. So final velocity minus initial velocity divided by time. So we all knows that final velocity minus initial velocity divided by time equals to something. What is that, everybody? Which is equals to, yes, please. Acceleration. Rate of change of velocity. Am I right or wrong, everybody? Yes, please.
Yes, sir.
Change of velocity. Rate of change of velocity is only called as acceleration. So force F is equals to m into v minus u by t. We can write it as a what, everybody? M into a. So this is only ways to called as what? Newton's second law. But if you observe very carefully, change in momentum, somebody remains constant. Velocity is changing, but who is remains constant here? Everyone? Always, everyone? So Newton's second law. So m is always remains what? Fastly respond. M is always remains fast. M is always remains is equals to what? Constant. So remember, this F is equals to MA is not true in all the cases. Why means? So let us discuss now, sir, why it is. Okay. So can you able to understand till here how to derive Newton's second law? Please respond. Monish, Rudeshwar, Pradosh. Now if you are, yes, ask me. Any doubt? Inara, can I continue? Okay. So as I said, F is equals to MA is only true when M is always remains constant. For example, let us observe very carefully. We all people knows the rocket. Am I right or wrong? Spaceship or rocket, whatever it is. So how the Newton's again go back to the class 9th and study. Of course, rocket will work in the principle called as every action is equals to reaction. Am I right or wrong? When the hot gases are pushing from the backside, from the tail of the rocket, so the gases are moving downward direction. That is what action. So that every action there is a equivalent. All of you, there is equal and opposite reaction. That is how the rocket will goes forward. Now, the gases, if you have taken this rocket, all of you observe. So now you tell me, is this rocket, the gases exhausted by this rocket is always remains same or always the mass of the gases which is exhausted is always remains constant or varies? That is what my question to you people. All of you respond. The exhaust gases, the mass of the gases exhausted is remains constant or mass will change? Yes, Pradosh? Sai Karthik? The mass will always remains not constant. The amount of gases which is exhausted is not always remains what? Everyone respond. Remains constant. So mass of the gases is not true. It is not constant always. It will be varies. So varies in the sense of then what is that? F is not equals to MA. Means in the sense of what? It is a valid. F is equals to MA. Is valid or not valid? F is equals to MA is not valid. Because F is equals to MA, M must be constant. But here M is not constant. Then what we have to do it? So in this case, F is equals to change in momentum divided by change in time. This is also used to called as what, everybody? This is also called as what? Second law only. So this is always true, always. This is always a valid one. Because we all knows that momentum is not only the directionally proportional to what is the momentum formula? Mass into, everybody. into velocity. So if you observe very carefully, momentum is not only depends on mass, momentum also depends on what? Momentum directly proportional to mass and momentum directly proportional to, please respond, velocity. So even though mass can affect, or both can also change, mass maybe remains constant, or velocity maybe remains constant, maybe mass maybe changes, or else both can vary. So that is what you have to remember. So here the amount of gases exhausted by the rockets is not always true. So that is why we have to remember that, yeah, in this case, F is equals to ma is not valid, but what is correct? F is equals to change in momentum divided by change in time period. Ellame Purema, please respond. Yes, all of you? Yes. Now, if you observe very carefully, now one interesting thing I'll say, for example, let me consider I'm having some object. Okay, so who is having a speed v, which is almost is equals to c. C means what? You all people knows. What do you mean by c? In 10th class we studied. Speed I am speaking. Speed c will represent with something. What is that? C is what?
Speed of light in
Speed of light in air. Do you remember? Speed of
Yes, sir.
light in air walking.
Yes,
That
sir.
is, which is equals to c. Then you remember, for example, I am saying you, when I parked my car, all of you remember, when I parked my car is at parking. Car is at parking or parking car, if you have noticed it. And when the car is in motion, that is what any object, I am not talking about car, any object. Keep in mind, when the parking car is in stationary or in case of rest, its mass is m0, m0, you assume. But when the same car is in motion, all of you remember, 9th class will study mass is always remains what? Everybody. Mass is always remains. Please respond. Mass is always remains constant, but the mass is not constant here. So that is different. When you are in a motion, you will be having some other actual mass. When you are in a rest, you will be having some other mass. So this is only ways to called as the most important Einstein theory, the very popular Einstein theory. That is what we used to call as theory of what? Everybody, theory of relativity. Okay, so when our body is in motion, it will be experiences the is their actual mass, and when it is in state of rest, it will be having some other mass, rest mass. Okay, so now when this is what, so how to find the actual mass? So if you want to find the actual mass, then the formula is equals to capital A, sorry, m means actual mass is equals to m naught. What do you mean by m naught, everybody? The object mass in, when it is in what? Rest mass divided by root over 1 minus v square by c square. So this is the formula for calculating mass, actual mass and as well as rest mass. So always remember, actual mass is always depends upon, like always depends, it is not constant when the rest mass. But in 9th class and all we study, mass is always remains constant. So remember, when the object is in rest mass is different, and actual mass when it is in motion, and that is different. So how to calculate it? Let us see that. For example, I will consider the speed is equals to c by 2. Understanding, everybody? The speed of light is equals to speed of light in air divided by 2. Do you all understand? Please respond. Example I am taking. Okay, then you can find it what is the actual mass. So actual mass is equals to m naught divided by root over 1 minus, in place of v, what I can write fastly, I can write as a c by 2 divided by c square. Am I right or wrong? All of you have to tell me. So m naught divided by root over 1 minus, this will become c square by 4 divided by c square. Am I right, guys? Fastly, nothing is there means 1 will be there. So that what will happen? M naught root over divided by 1 minus c square by 4 into 1 by c square. So c square will get what? Fastly, cancel. So which is equals, you should speak, which is equals to what will happen? M naught divided by root over 1 minus 4. Am I right? Sorry. Yeah, you can take it. But I think here I have done some mistake. Am I correct? It is wrong. So I have done mistake. Correct? I forgot to take the LCM. So here is the wrong step. So what do I have to do it here? Anybody can tell? C square by 2 divided by C square. So nothing is there means 1. So it will turns into what? C square by 4 C square. Am I right, guys? All of you?
Yes,
Yes.
sir.
Yeah. Then what is the LCM? So LCM is how much? LCM is 4 C square. So here only 1 is there. So 1 means I have to multiply with what? 4 C square minus C square. Okay. Up to male, what will be there? M naught. Am I right? Yes.
Sir, 1 minus 1 by 4 will
1 minus 1 by 4.
1
Okay.
by
Yeah, that is also. Shall we do it like that? C square will get cancelled. So that is also we can do it. Then what is the remaining, Pradosh?
Root over 3 by 4, sir.
Root over here 3. Let me take 4. I will take the LCM. So here 3 minus 1 will be there. 3 minus 1 or 4 minus 1? 4 minus 1.
4 minus
4
1.
minus 1. Very good. So M naught divided by root over 3
root
by
over 3 by
3 by
4.
4. So can I write this one as M naught into root 4 divided by root 3? Am I right or wrong?
Yes, sir.
Yes?
Yes, sir.
Yes. Now if you notice it, so this is not M. So small m is equals to M naught into root 4 by root 3. So definitely here M is actual mass is greater than M naught or it is less than M naught. Definitely it is greater than M naught. Why? M naught into root 4 by root 3 only will gives you what? M. Am I right or wrong?
M.
Everybody? Yes or no, guys?
Yes, sir.
Yes, that is what. So M is greater than M naught. So if you notice it, then in this case also, when the rest mass is, actual mass is greater than the rest mass, then in this case also, what will happen? F is equals to ma is not valid. Clear? So that is what you have to remember. So in these cases also, be very careful. 95% of cases from class 9th, 95% of cases, M is always remains what? M is always remains constant. And M is constant means you can use a formula. F is equals to what? Mass into acceleration. But very few cases, that is what, just 5 cases, if you have taken, M is not constant. M is not constant. So in these cases, what is true? F is equals to dp divided by change in momentum divided by change in time period. Clear? All of you? Understand, everybody? Please
Yes,
respond,
sir.
Aswita. Understand, Aswita? Anand, Samaya. So this is what you have to remember. Mr. Monish, Sai Karthik, any doubt you can ask me. Okay? Now, if you observe, so can you anybody tell me what is the differentiate form of Newton's second law? Differential form of differentiation. Differential form of, very important, because let me take the change in momentum is extremely smaller. Yes, Rudreshwar, what we can say? Very small interval of time, almost 0. Then we all know the differential form of force F is equals to dp by delta p by delta t. So I want very, very small interval of time. So that what will happen? Modify everybody fastly. Very small change in momentum. Very small change in momentum. So that delta p modified into something. What is that?
dp by dt.
dp by
dp by
dt. Very, very important. Okay. So this is what I want it. Okay. All of you, please respond. Now, we all knows that P is equals to what? Mass into fastly, mass into velocity. So F is equals to dp by dt, which is equals to d. P value how much ra? P value m into v. Am I right? Divided by dt. So now UV formula, tell me differentiation of UV. We all knows that. Rudreshwar, can you tell me, do you UV formula? What is the formula? Not saying no use of this. So what is the formula? U into dV by dt plus V into du by dt. Am I right or wrong? Yes. That is what you have to learn it. Unless you remember, you cannot. So same way here, M and U, apply the formula. So what will happen? First, M is constant. So M dV by dt plus V dm by dt. Okay, wow. Please respond, Ra. All of you. So this is only we used to called as UV rule. Now, so if you apply this, this is what actually the exact Newton's second law. exact Newton's second law, which is always remains true. Okay, always true. So what is always true, everybody? The force equation, differential form of force equation is the perfect equation of equations of motion. For the Newton's second law. Ellame Purima, Sai Karthik, Mr. Prince, Pradosh, Princey, any doubt you can ask me.
Sir.
Okay, Aswita, understand Aswita?
Yes, sir.
This is the exact form of second law. Exact form of second law, which is always remains what? Everybody. Always remains true. Understand, Rudreswar? Okay.
Yes,
So here you should remember M is constant or not constant? Change in mass. Change in mass is not constant. Purima, because it is a what? 5% cases. Yes or no? So change in mass is 0. Okay. And you remember M is not at all constant here. If you see M and V, so M is not constant. So that is what you should remember. Or if you consider M is a constant, then dm by dt will become what? Suppose if I consider dm is a constant, then dm by dt will become what? Fastly should tell me. dm, if I consider m is a constant, change in mass is 0. Be very careful. Change in mass is 0 means mass is remains constant. Where is Rudreswa? Brothers,
constant.
change in mass is 0 means mass is remains constant. So constant means constant of, suppose differentiation of 2. What is the answer? Yes,
0.
Same way, dm by dt, which is equals to what is the answer? dm by dt, which is equals to 0. Understand all of you? So differentiation of m is 0 because m is always remains what? Constant. Okay, all of you. Then the formula will be modified into what? This for fastly. Formula into modified into what? m dv by fastly m dv by dt. Now dv by dt equals to something. Anybody can tell me? dv by dt
Accelerate.
acceleration. So f is equals to m into fastly. F is equals to m into a. That's all. Have you got the answer, everybody? So whatever it is, you will get it. The final answer is remains same. Okay, but what is the exact form of Newton's second law? This is the exact form of Newton's second law, which you all need to remember that. Clear? Ishali, Asita? Yes?
Yes, sir.
So very, very important. So this is only called as Newton's second law. Now we will solve 1 or 2 sums and then we'll continue. Further, I think soon we'll, at least by this month, then we'll definitely finish this chapter. So very important chapter. Next chapters and all, at least we have some small touch in lower classes, so that it will be more even easier. You can feel it. So this is what about it. Anybody having any doubt, please kindly let me know. Do you all understand or not? I want to know. Everyone?
Yes, sir.
Yeah. So the first question,
Yes, sir.
one more question I will send you after this class. First question. So take the question number 1. So how many of you know how to draw FBD, free body diagram? Ellame theriyuma? Free body diagram, how to draw? Clear? So we have to consider 3 steps. On the day I have taught you or not? 3 steps.
Yes, sir.
Yeah. So keep it in mind, only one object is there. Then the surface and the object always normal before the question. We wait before the question. So normal is always act upward direction, and gravitational force, that is what? Weight always act what direction? Fastly downward direction. Okay. Suppose if the block over the block, do you all remember that? This here 2 totally normal forces will come. One force exerted by the ground on this M object, so that is what? N. And then M object will exert the same force on the ground, that is also N. Then what about these 2 surfaces? Here also they are in contact. So this is M2 and this is M1. So here M1 will exert some normal force on N2. Then N2 is also will exert some force. Let me take, this is N dash. And yeah, this M2, M1 also will exert some normal force on M2. Am I right or wrong? Everybody?
Yes, sir.
Yes, and as well as here M2 is always normal force will act on the upward direction. So keep it in mind. Now here my intention is, whenever the surfaces are contact, 2 surfaces are contact, definitely you have to draw the what? Normal force, normal reaction exerted by one body and second body, and the second body and the first body. Ellame Purima, Laksha, that is what. So
Yes,
unless
sir.
you understand that, you cannot. So just you remember that. Okay. Next, the question which we are solving now is, So let me consider the question number 1 fastly, all of you. So the object or block has been placed who is having a mass m. Who is having a what? Mass m. And whose acceleration, weight, which is acting what direction? All of you, downward direction. And we all knows that normal reaction is always perpendicular. That is what? 90 degrees. So what is the value of normal? N. Am I right? You should speak. And you tell me, if the force is applied like this direction, then what about the acceleration? Acceleration is also same direction or opposite direction? Force is applied in this direction. So acceleration is also what direction? Fastly. Same direction. Yes or no, Ra? Yes, that is what. So
Sir.
imagine free body diagram. Draw FBD for this. Those are options you should learn. I will upload the videos tomorrow morning. You all please kindly watch it. So FBD means what? I want to know. FBD means what? Free body diagram. So consider this entire mass as a point object. Entire mass as a point object. Now one upward force is acting. That force is we used to call as normal. One downward force acting, which is what we used to call as. Okay, what is that mg means? Mg equals to mass into acceleration. Am I right or not? G means G is equals to A. A means acceleration due to acceleration of the body. G means acceleration due to
Gravity.
acceleration due to gravity. That is what you should understand. So when the object is falling downwards, you all see that normal force is acting upward direction and W is equals to mg. And you can see that force is exerting in this direction. So that acceleration is also same direction or opposite direction? Fastly. Same direction. That's all. So resultant force, you can see that you can add it. So from this one, this force is equals to this force because opposite forces. So N is equals to what will come? Fastly. N is equals to fast mg. So I found it normal force value. Now we want from Newton's second law, F is equals to ma. From that, A is equals to F by F by M. Am I right or wrong, everybody? Which is equals to F by, yes, clear or not? Please respond. F by M. That is what is very, very important. Now, so when we talk in very, very important one, if acceleration is equals to F net divided by time. Do you all understand what is that? F net means resultant force. What is that? All of you. Resultant force F net, or we can say, what is another name of this one? Resultant force. Yes, please. We used to call it as net force. What is to call, everybody? Net force, which will represent with the F net, or you can represent with the that is also another thing. What is that? We can represent with the net force, or we can represent, that is what resultant force we can take it. So resultant force, this is what F net, or it will take net force, which is equals to same, both are equal. Okay, so this is what about it. Then what is that? Many forces can act on the body. So what is the acceleration? F net divided by, everybody should have a patience. F net divided by what? Which is equals to F net divided by what, guys? Time. Okay, that is only we used to call as acceleration. That is what you should understand. Anybody having any doubt, you should ask. Clear understanding, everyone? Yes. Please respond, guys.
Yes, sir.
That is what. Next you take the same thing, like similar thing. So let me take now on rigid surface. I have a one block who is having a mass m. Now be careful. The object is moving forward direction like this. And this is another arrow which is moving, applying the forces on equal direction. But I'm giving acceleration is like this one. So means in the sense of whose F1 is greater or F2 is greater. From this one, from this figure, you tell me F1 is greater or F2 is greater. I found acceleration is like this forward direction. So that you tell me acceleration is positive or negative. Obviously, acceleration is a what? Please respond. Acceleration is what? Positive or negative? Acceleration of Earth is always what? Always it is a positive. So how much it is? 9.8 meter per 9.8 meter per. Respond, Ra. Yeah. So we all knows that whenever the object is acting, be very careful here. Now the object is moving like this direction. If it is moving like this, indicating that who is dominating? F2 is greater than F1 or F1 is greater than F2 or? F2 is
F2
greater
is
than F2. The same object, if you take acceleration due to gravity, for example, object is falling like this. So we all knows that in this case, body is accelerating with what? How much it is? Acceleration of Earth. Attraction towards the Earth, 9.8 meter per
Meter per second.
second square. Okay, meter per second square. So we all knows that. Now acceleration is like this direction. So now, if you observe very carefully, body is applying this direction and this direction F1 and this direction F2, but finally body is moving like this direction. So F2 is greater than F1. So now, if you draw very carefully, all of you observe, tell me what is the forces are acting on this body. This is what F2 and opposite direction. This is what is to call reverse direction. You should tell me. That is what F1 and down somebody is acting. What is that? Down somebody is acting. Weight and
Weight.
opposite to the weight somebody is other acting. Who is that? Normal. Understanding? Please speak. Normal. So we all knows that these both are equal. So that n is equals to always will get what? N is equals to mg. Then these both are not same direction. I think 8th class you might be studied. If it is same direction, addition. If it is opposite direction, subtraction. Then what will happen here? F2 minus forward minus backward. So that what will happen? F2 minus F1. That is what we used to call as force, change in force. So F2, because we all knows that F2 is greater than F1 or F1 is greater than F2. Everyone? F2 is greater than F1. So that F2 minus F1, which is equals to mass into acceleration due to gravity. That is whatever it is. If it is a freely falling, you can say A is equals to Z, or we can say A means simply acceleration. G means everybody. G means what? Acceleration due to gravity. Okay. So in this case, this change in force, if you want, you can write delta F. Delta F is equals to M into A. Or you can write simply F is equals to what finally? F is equals to M. That's clear. But here F means you should write F is equals to what? F2 minus
F1.
F1. Okay. That is what. If you get a free fall case or whatever the case, this is what you should understand. Any doubt, anyone? Please let me know. Clear, everybody? All of you?
Yes, sir.
Yes?
Yes, sir.
Yeah, please proceed, solve it. So next question. I will draw the question by the time you solve the question. So one rigid surface having a block of mass M, having a block of mass M, having a block of mass M, and the force is exerted inclined F, that is what, with the theta degrees. Okay, 9th class, brothers, do you remember boy is dragging the toy and all? How you will find cos theta? Similar. Okay, so that is what it is here. Anybody having any doubt, you can ask me. Do you all understand, everybody? Aswita? No, this is a question. What they are asking here, if you observe. So theta, with that angle theta, we are exerting the force on this. Then they're asking, find normal and as well as acceleration of a body. Normal, N means, keep it in mind, normal reaction. What is N means, everybody? Normal. So which is always perpendicularly to the surface. Now, immediately here some force is acting downwards. If this is the question, then we all knows that. Let me take this is considered as a FBD. So FBD means what? You all should speak. FBD means what? Free body diagram. So let us imagine that